Now we have to derive the Lorentz transformation equations. For that, we need two frames of reference. One is S frame and another one is S dot frame. The S frame is at rest. O is an observer in the S frame, whereas the S dot frame is moving with the constant velocity along the positive x direction alone. There is no relative motion along y and z direction. O dash is an observer in the S dot frame. The S dot frame is moving with the constant velocity v along the positive x direction alone, means it is not moving in the upward or downward directions. At t equal to 0, both the observers as well as the frames coincide with each other. At t equal to 0, O equal to O dash. At t equal to 0, both the frames coincide with each other. After a time interval t, the S dash frame is at a distance vt, because velocity equal to distance by time. Distance equal to velocity into time. So after a time t, the new position of the S dash frame is v into t. At t equal to 0, we pointed out earlier, both the frames coincide with each other. At that moment, consider a flash of light is coming out of the system. The light waves are propagated as spherical wavefronts of increasing radius. At t equal to 0, the light waves are coming out. The observer O predicts the outgoing wavefronts after the time t, and he finds the wavefronts at the point P if the time interval is t. The position of the wavefront after the time t is P for the observer O, whereas for the observer O dash, the wavefront has reached the point P after a time interval t dash. The observer O predicts the position of the wavefront at a radial distance r, whereas the observer O dash predicts the wavefront at the point P, which is located at a radial distance of r dash. 2 points you have to concentrate. At t equal to 0, the wavefront is originating. The propagating wavefront is increasing its radius. It is a spherical wavefront of increasing radius. After the time t, the position of the wavefront is predicted by the observers O and O dash. The observer O predicts the point P at a distance r from the origin, whereas the observer O dash predicts the point P at a distance r dash from the origin. The time taken by the wavefront to reach the point P is t for the observer O, whereas for the observer O dash, the time taken by the wavefront to reach the point P is t dash. From the diagram, we can write r square is equal to x square plus y square plus z square. Therefore, x square plus y square plus z square is equal to c square t square, because displacement equal to velocity into time. For the observer O dash, the time the light required to reach the point P is t dash. Therefore, r dash is equal to c into t dash, because the velocity of light is constant. R dash square is equal to x dash square plus y dash square plus z dash square. Therefore, x dash square plus y dash square plus z dash square is equal to c square into t dash square. Now, equation 1 must equal equation 2, since both the observers are at the center of the same expanding wavefront. Now we have to write x square plus y square plus z square minus c square t square equal to x dash square plus y dash square plus z dash square minus c square t square. There is no relative motion along the y and z directions. Therefore, y square is equal to y dash square, z square is equal to z dash square. Then the above equation 3 is modified as x square minus c square t square equal to x dash square minus c square t dash square. This is t dash. Say this is equation number 4. To get the Lorentz transformation equations, we have to assume the value of x dash equal to some constant k into x minus vt. X dash equal to x minus vt is our Gaussian transformation equation, but x dash is equal to k into x minus vt. This is our Lorentz transformation equation, and we have to assume t dash is equal to some constant a into t minus another one constant b into x. So this is equation 5. This is 6. Here k, a and b are constants. We have to evaluate their values. Substitute the value of x dash and t dash in equation 4. X square minus c square t square is equal to, instead of x dash we have to substitute this here, x dash square. So k square into x minus vt whole square minus c square into the value of t dash is a, t dash square means a square into t minus bx whole square. Now make the square of this. This is equal to k square x square plus v square t square minus 2x vt. A minus b whole square is equal to a square plus b square minus 2ab minus c square a square into t square plus b square x square minus 2tbx. Expand this. This is equal to k square x square plus k square b square t square minus 2 into k square x vt minus c square a square t square minus c square a square b square x square plus 2c square a square tb into x. Now you have to align the terms. Align the, see in the left hand side x square term is present. So take the x square, align the x square terms and take x square as a common one. This is having x square, then this term is having x square. Now combine those two terms. K square minus c square a square b square into x square. Then see here minus c square t square term is available in the left hand side. Now we have to align the terms with the minus c square t square. See here, this is the term with minus c square t square. And this is the term with t square, but no c square is present. Anyway, take this minus c square t square outside. Minus c square t square into, already we have taken minus c square t square, so the remaining term is a square. Now come to this term, only t square term is present here. We have taken out minus c square t square as a common term. Therefore, this is minus k square v square by c square. So we have combined these two terms. This is 1. These two are 2. See here, minus c square t square. Remaining term is a square. Then already we have taken out minus sign, minus t square. But no c square is present here, so minus k square v square by c square. Now multiply, you can get the original term. Minus c square t square into a square, this term. So minus into minus plus. C square cancelled out. So plus t square k square v square. You can get this term. Only two terms are remaining in the right hand side. Now we have to align them. See here, the remaining terms are minus 2k square x vt plus 2c square a square tbx. Now we have to modify this. This is equal to k square minus c square a square b square into x square minus c square t square into a square minus k square v square by c square. Now take out minus 2xt as a common term. If you take minus 2xt, we can have k square v here, then minus 2xt with a negative sign. So that remaining terms are c square a square, then 2xt tx c square a square b. This is the remaining term. Verify this. We have taken out minus 2xt k square b. Here 2 we have taken out, c square a square b, then t into x already comes out, so with a minus sign. Now think about our left hand side. The left hand side is x square minus c square t square. X square minus c square t square, which is equal to k square minus c square a square b square into x square minus c square t square into a square minus k square v square by c square minus 2xt into k square v minus c square a square b. Say this is equation number 7. Now equating the coefficients of x square, then c square t square and this 2xt term. On equating the coefficient of x square, say on equating the quotient of x square on both sides. K square minus c square a square b square equal to 1. Then on equating the quotient of c square t square. See here, c square t square, 1 into c square t square. So this term should equal unity. A square minus k square v by c square equal to 1. Now equate the coefficient of this 2xt term. No 2xt term is present in the left hand side, so this could equal 0. On equating the quotient of 2xt, then we can write k square v minus c square a square b, c square a square b equal to 0. We have had 3 equations. This is 8, this is 9, this is 10. Then from equation 10, k square v equal to c square a square by b. Then k square equal to c square a square b by v. In order to make k square equal to a square, put b equal to v by c square. If you put b equal to v square in this equation, this is 11. Put b equal to v by c square in 11. Then we can get k square is equal to c square a square divided by v into v by c square, which is equal to a square. Now we have had one result, k square is equal to v by b equal to v by c square. The value of b equal to v by c square. Now come to this first equation, 8th equation. From equation 8, from equation 8, what is 8? K square minus c square a square b equal to 1. Check it out. K square minus c square a square b square equal to 1. Oh, this is k square minus c square. Already we have proved that k square is equal to a square. If you put b equal to v by c, k square is equal to a square. So that instead of this a square, we have to put k square. Then this b square is b by c square whole square, that is equal to 1, because b equal to v by c, so b square is v by c square whole square. Now take this k square as a common term, 1 minus this, take k square is taken out, c square into v square by c power 4 equal to 1. This is k square into 1 minus v square by c square, that is equal to 1. K square is equal to 1 divided by 1 minus v square by c square. Then k equal to 1 divided by root of 1 minus v square by c square. Now we may write a equal to, the values are known to you, a equal to k equal to 1 divided by root of 1 minus v square by c square. Then what's the value of b? B equal to b by c square. This is the value of b. Now x dash equal to k into x minus vt becomes x minus vt divided by root of 1 minus v square by c square. This is Lorentz transformation equation. X dash equal to x minus vt divided by root of 1 minus v square by c square. There is no relative motion along y and z direction. Therefore, y dash is equal to y, z dash is equal to z, t dash equal to a into t minus bx. The value of a is also 1 divided by root of 1 minus v square by c square. T minus b, that is v by c square into x divided by, the value of a is 1 divided by root of 1 minus v square by c square. 1 minus v square by c square. Then t dash equal to t minus v by c square dx whole divided by root of 1 minus v square by c square. These are all called Lorentz transformation equations. X dash is equal to x minus vt divided by root of 1 minus v square by c square. Y dash equal to y, z dash equal to z, t dash equal to t minus v by c square into x divided by root of 1 minus v square by c square. These are all called Lorentz transformation equations. Then the inverse transformation equations are x equal to x dash, see here, x dash is equal to x minus vt, x equal to x dash plus vt, minus v is changed as plus vt divided by root of 1 minus v square by c square. Y equal to y dash, z equal to z dash. Then t equal to t dash plus v by c square x. Here this minus v is changed as plus v. T equal to t dash plus v by c square into x divided by root of 1 minus v square by c square. These are all called inverse transformations.